Stop looking at my bushy eyebrows and just pay attention. We have a test Friday. Make sure you learn this new equation. Alright, our topic today is exponential growth, and the formula is similar to the other one, except that because this is going to be more involved with money, it's going to look more like a financial formula. So y equals a times 1 plus the rate times over raised to time. So where a is still the initial amount, r is the growth rate, and t is time. So what we're going to be working on is word problems, and all we have to do is identify that a, that r, that t, and then we're just going to put it in the calculator. So the only one that you're going to see me put in the calculator is number 1. Then all the other ones, you just know that as I will go through the steps, I'm putting it in. So number 1 says the original value of an investment is $1,400. So there's our initial, and the value increases by 9%. There's our rate, and use it in each year. Use an exponential growth function to find the value of the investment after 25 years. There's our time. So again, if we identify our A as $1,400, our R as 0.09, and I know it was 9%, but we need to put it in decimal, and T is 25. Then we can create the formula 1,400 times 1 plus 0.09 raised to the 25th. Now all we're going to do is put that into the calculator, and I'll show you what that looks like. It's not the best look in the world, but it'll get it done. So again, we're going to do 1,400 times 1 plus 0.09 raised to the 25th power. We hit enter, and because we're talking about money, that is $12,072.31. So we're going to put that in here. Our answer is $12,072.31. And that's how we're doing all of these. So it looks like a lot of notes, but what you're really doing is identifying your A, your R, your T, and then putting it in. For example, number 2. The cost of tuition at a college is $12,000. There's our initial, and it's increasing at a rate of 6%. There's our rate. Use an exponential function to find the tuition cost after 4 years. So 12,000 times 1 plus 0.06 raised to the 4 years. Okay, so again, our A was 12,000, our R was 0.06, and our T was 4. When we put all that in, so 12,000 times 1 plus 0.06 raised to the 4, that's what you should be putting in your calculator. You should get 15,149.72, and that's money. Okay, let's go to the third one. It says the number of student athletes at a local high school is 300. There's our initial value, and it's increasing at a rate of 8%. There's our rate. Use an exponential function to find the number of student athletes after 5 years. So our A is 300, our R is 0.08, and our T is 5, which makes our formula y equals 300. I guess I kept leaving the y out of the other ones. Please know that the formula would be y equals 300 times 1 plus 0.08 raised to the 5th. When you put that in your calculator, you're going to get 440 student athletes. Okay. The next one says an annual sales for a company are 149,999. That is our initial, and are increasing at a rate of 6% for 7 years. So again, we identify our A as 149,999, our rate to be 0.06, and our T to be 7. We write our equation, Y equals 149,999, 1 plus that rate of 0.06, and we raise it to 7. When we put this in the calculator, we should get 22. So what is that? That is 225,543.04. And this one is also money. Most of these are going to consist of money, but as you saw, number 3 was talking about student athletes. Number 5, the population of a small town is 1,600. There's our initial, and it's increasing at a rate of 3%. Use an exponential function to find the population of the town after 10 years. So, again, our A is 1,600. Our rate is 0.03, and our time is 10 years. So, Y equals 1,600, 1 plus 0.03 to the 10th power. And that equals 2,150 people. This is not much different than Y equals ABX. The reason for the 1 is that we're already accounting for that year that it began with, and that'll make more sense as you see what's going on. So in 1985, there are 285 cell phones subscribers in Mayville. The number of subscribers increased by 75% per year after 1985. Find the number of subscribers in 2008. So we're not going to use 2008 for our year. We need to find out how many years that is. So first we take 2008, subtract 1985. That tells us that is 23 years. So we've identified our A as being 285 subscribers, our rate to be 0.75, and our time to be 23 years. We then use that to create our formula, which is 285, 1 plus 0.75 raised to the 23rd year. You're just going to put that in the calculator exactly how you see it, and you should get 110,845,988 subscribers. So again, don't worry too much about remembering the formula. This formula will be given even on test day. What you have to know is how to use it. So this is what it looks like when it's growth. When it's decay, it's going to be the same, except the decay means that it's subtracting. So the same thing, our decay formula is Y equals A1 minus R raised to the T, where A is still initial, R now is decay rate, and T is time. So again, we read number 7. The population of a town is decreasing at a rate of 1% per year. In 2000, there were 1,300 people. There's our initial. Use an exponential function to find the population in 2008. So from 2008 to 2000, that was 8 years. So we have our T to be 8. We have our rate to be 0.01, and we have our A to be 1,300 people. So the only difference here is because it's decreasing, we're going to say 13. So Y equals 1,300, 1 minus 0.01 to the 8. And that's the thing. We'll provide the general formula, but you need to understand when it's decreasing to use minus. When you put this in your calculator, you're going to get 1,200 people. Most of the decreasing is going to involve populations. There's some that's going to involve money, but most are going to involve population. Now, number 8 involves money. The value of a car is $18,000. There's our initial, and it's depreciating. That means it's decreasing at a rate of 12%. What would it be worth after 10 years? So our A is 18,000. Our R is 0.12, and our T is 10 years. So you always hear that cars depreciate. This is how we find the depreciation value. 1 minus 0.12 raised to the 10. When we put that in the calculator, after 10 years, this car will be worth $501.30. So we're not finding how much it's depreciating, that's how much it's actually going to be worth. Number 9, a farmer buys a tractor for $50,000. If the tractor depreciates 10% per year, use an exponential function to find the value of the tractor in 7 years. So again, A is 50,000, R is 0.10, and T is 7, which gives us an equation of y equals 50,000, 1 minus 0.10, right? And raised to the 7th power. When we put that in the calculator, we're going to get $23,914.85. Remember, if you're not getting the same totals that I am on the video, just recheck that you're raising it to the right power and that you're doing every step correctly. Number 10, an investment of $8,200 loses value, so it's decreasing at a rate of 2%. Use an exponential function to find the value of the investment after 9 years. So again, A equals 8,200, R equals, what was our rate? 0.02, and T equals 9 years. So Y equals 8,200, 1 minus 0.02 raised to the 9 years. We put this in, we're going to get $6,836.73. So all these things, investments, cars, they all lose value, if sometimes. Number 11, the initial value of a book is $58. Books also decrease, and this is decreasing. You know, when you buy a book in college, you're going to find out that you pay $50 for it, but then when you want to pass it on to somebody else, they're going to only pay you $20. So this book costs $58. It's decreasing at a rate of 7% for 8 years. So A, $58. Our rate is 0.07. Our time, 8 years. No book lasts 8 years, but especially not nowadays. So Y equals 58, 1 minus 0.07 raised to the 8. We put this in the calculator and we get a value of $32.46. Man, if a book is still worth $32 after 8 years, I need that book. I can make some money. And the last one here, the population of a town is decreasing